Hi guys, this is Dilip. Uh, Hi to everyone. Good evening. Actually, I know it's a Friday evening, but still, uh, we'll be having a good session today about the DB testing. Actually, about myself, I'm an ETL tester. 6 years of experience, and I'm with Moolya for about past 1.8 years. And I have an experience in ETL testing, manual testing, automation testing, and I worked with different domains like PeopleSoft, insurance, healthcare, clinical trials. Okay, and to start with, this session is about what is database testing and what are the techniques used in database testing. Okay, and just giving this session in order to educate you about the importance of it, and also in the end of the session will make you perform a better database testing if you're already doing it. Okay, so and which will in turn will improve the product quality. Okay, fine. So if you have any questions, you can just raise a hand in your chat option, and if you have any questions also, you can type your questions in your chat window so that I can acknowledge. Okay, so let's jump into the session. So this is the topics which I'm going to now cover. So what is database testing? Why database testing? Where it is used? Types of DB testing? Things you should know being a DB expert, and DB testing process, database testing techniques, myths related to database testing. Okay, and okay. So what is database testing basically? So what is database? So it is collection of information data, right? So tables which has rows and columns. So you'll be testing those tables, which is inside the database, is database testing in a high level. Okay. So it involves like checking the schema, tables, stored procedures, views, triggers, etc. of a database. So we have different functions inside a database, right? So tables. So we have different tables with rows and columns, which have all the data set. And also we have triggers, which is an automatic stored procedure event. Which occurs for every event. Okay, so we'll be checking all these things. And it also includes performing a data validation, data integrity testing, and performance check related to the database. And it involves creating complex queries to load test the database and its responsiveness. And also it is usually consisted of layered process that includes the user interface, the UI, the data access layer, access control list, which we call it in database terms, APIs, ETL tools, and the database. Okay. So ACL is something which deals with all the access levels. Okay. So it's access control list, we call it as. So why database testing? Okay. So man believes in what he sees, but a coin has two sides, right? And I know this is a usually used idiom in English, and even it is used in testing as well. Okay. And similar is the case with the UI and the database. Okay, this data has two sides, one side with UI and one side with database. So that is why database testing is so much needed, and also it solves problem. Okay, I'll tell you what sort of problems you will get it in the next slide. Okay, I'm just giving you an a real time example, real time scenario which we face day to day between testing teams. Okay, between the UI testing teams and between the database testing teams. Okay, so just guys, assume there's a patient who's undergone a surgery. Okay, and he's been advised by a doctor to monitor his glucose levels using the glucometer, and he's advised to to feed those glucose levels 3 times a day for 30 days in an application which is provided by the doctor. Okay, so and later on with the data which is feed by the patient, doctor will have a metric dashboard which will guide the doctor for the post treatment activities. What kind of diagnosis we can do, what kind of medicines we can give, what kind of diet we can advise, all those things. Okay, so first comes the glucometer, and the patient feeds the data into the application. Okay, and now the according to the data, some dashboard is being displayed in the doctor's application. So we have two end users for this application. So one is the patient, another one is the doctor. Okay, so if you see 120 here in the glucometer, it's being fed by the patient into the application. And but if you see the metrics dashboard, it says 108. Okay, in spite of having multiple calculations and logics behind it. Okay, but still, if you see the glucometer here, okay, I'm just pointing out here, 118. I hope you can see this 118 here, which is showing in the patient's UI. Okay, it shows 118 in patient's UI, and it shows 108 in doctor's UI dashboard. Okay, which is a bad data. Okay, so 118 is different, 108 is different in terms of glucose level. And again, if the doctor is coming to see this 108, and he might have his own medications and advices for these levels, but the patient is not having this 108, it's having 118. Okay, so it's a bad data, it's a bug actually. So now how can we mitigate this these errors? Okay, so now comes now the database data warehouse into picture. Okay, so the patient, the data which is fed by the patient in application being stored in a database as an OLTP transaction. Okay, and it's been ETL'd to a data warehouse. Okay, so where the data, the BI designers, so the dashboard designers basically will use the data warehouse data to fetch and create the queries in order to display the dashboard actually. So this is why database testing is much needed in order to maintain or backtrack the miss and to maintain the product quality. Okay, hope you're with me, guys.
Yes, Dilip.
Okay, yeah, thank you. Okay, so where it is used. Okay, so when a software deals with database, okay, DB testing would intervene. Okay, and we have an evidence even in 19th century. The DB testing was done by a bookkeeping using bookkeeping actually. So in 1831, right? So we have an evidence of a retail bookshop, okay, which where a clerk who's working in that shop is noting down all the transactions which he is selling to the customers in a rough book, okay, with all the date, time, and price. Okay, so in the same rough book, a shop owner is entering all the purchased product details. Okay, with what type of product he purchased, what is the price when he purchased, etc. Okay, so these two transactions. So the product which is sold, this product which is bought, both these two transactions are being carefully typed into a day book. Okay, so now rough book is not in the picture, day book comes into the picture. Okay, so in this day book we have all sort of transaction about which is sold and which is purchased. Okay, so these transactions again being reviewed by an account manager, and he's moving these data into a general ledger, okay, which will have a credit and debits. Okay, so which is nothing but a real time this is actually a manual process where you will be typing all the transaction carefully without any miss. Okay, so this is a small example of an ETL process. Okay, how the data been getting to the source and how it's been transformed into a general ledger. Okay, in 1831, I guess, 19th century. Okay, but now even it's used in the emerging technologies like data science, IoT, machine learning, reporting and statistics, cloud computing, blockchain, virtual reality. Okay, this is something about where it is used actually. So next we will just jump into types of DB testing. Okay, we have different types of DB testing, guys. Just explain what are those. Next is like the black box testing. Okay, so black box testing, which involves testing the interface and the integration of the database, like mapping of the data, verifying incoming and outgoing data. So if data is there, there should be an incoming side and outgoing side, right? So similarly, in database it is done. And CRUD, again, you know what is CRUD? Create, read, update, delete. Read is nothing but select. So what about the data which is created, whether it is flown to the database? So whether I'm able to see that data, selecting the data. Okay, and what if I'm just going updating the data, whether I'm able to see the updated records of the data? And what if I'm deleting the data, whether I'm able to see the data or not seeing the data? Okay, it depends on the requirement. Okay, and again, so various techniques with equivalence, partitioning, and boundary value analysis, which you guys know about it. Okay. And next is like white box testing. White box testing is basically deals with internal structure of the database. We'll be testing the internal structure, like the views, triggers, and ETLs involved, the schemas, what is the data model involved in database. All those things will be tested in a white box testing. So the important advantage of white box testing is like the coding errors are detected, so internal bugs in the database can be eliminated. And this is about white box testing actually. And next thing is like performance testing. It's basically load test. Someone is scribbling on my screen. May I know what is the issue? What is the question? Do you have any questions? Okay, some chats. Guys, you're able to hear me?
Yes.
Yes, Dilip.
Okay, fine. Okay, I think Suraj, do you hear me? Suraj, Sarat Kumar.
Yes,
Yeah, I
Dilip.
think it was in the.
We are able to hear.
Okay, fine, fine. Thank you so much for the confirmation. Okay, so I mean, next is performance testing. So it basically involves a load testing actually for database to stress test the database. So it's actually not commonly tested by all the database testers. If you have dedicated performance engineers who perform these kind of testing. Okay. And we have other types of testing as well in database. Uh, how can I remove this scribbling? Any idea?
You can see an eraser there. You should take it and erase it.
Okay. I'm not able to see it actually.
You can go to more options and you can see that there.
Okay. Okay. Thank you. Okay. So other types is like database migration testing. Okay. And so what is database migration testing? So if data has been migrated from one database to another database, so we will be testing those data. Okay. So for example, IBM DB2 to Oracle DB. So we are migrating all the data from IBM DB2 to Oracle DB. So we should test whether all the data has been loaded into the new database. Okay. So assume there are 10 million records, 10 million data are in DB2. Okay, so how can we test all the 10 million data? So here comes sampling. So in order to test all these 10 million data, which is not possible. So we do sampling, sample test. Okay, we'll be taking samples of each scenarios and we'll be testing it. And this testing will be an iterative method. Like you cannot say your testing is done by completing one round of iteration. You should do 2 to 3 iterations in order to uh, to get the entire quality of the data. Okay. Okay. Unable to view the slide. May I know who will select those data? Okay. So that's a good question actually. Testers should select the data actually. So we will be having a mapping document, right? Um, for each and every transaction, for each and every logics, we will be having scenarios. So being a database testers, you will be selecting a data scenarios and the samples which will satisfy those scenarios, and you'll be testing this samples. Okay, I think we have one more chat. Okay. Sampling is not considered as a testing technique. Okay, it's a method to test data migration. So next thing is like database conversion testing. Okay. So what is database conversion? So conversion, so legacy files to database conversion. So we'll be having various source files. Okay. So data cannot be stored directly into a database. It should have some source files like flat files. Okay, flat files, fixed files. Okay, which is not an ordered thing. If you get the mainframe files, you'll be getting in-ordered fixed files and flat files. Okay, so those are the source. So how can I convert into uh, a valid structured format? So it's done by an ETL again. Okay, so and it will be loaded into the database, maybe an Oracle or Redshift or IBM DB2, and there we will be starting out testing from the flat files to Oracle, or from the legacy files to the exact database testing. Okay, so here we will be doing a black box and white box testing. Okay, to ensure the data quality again. Okay, next is reports testing. Okay, so what is the end output of a database? In order to for all the data scientists and data analysts, they will be showing or showing their reports, showing the data in the reports in a BI, business intelligence, like SAP BO, Crystal, IBM Cognos reports, Oracle BI Publisher, TIPCO, Spotfire. All these things are BI tools which will be used to represent or show off the data in a fancy formats, which will help the clients to identify what sort of data to analyze easily to be in high level. Okay, so all these reports are designed using SQL queries in the backend. If you just open the BI universe and see, you will find all the SQL queries. So all the data should be coming from the data warehouse database. So we have a few chats. Okay, I think. Okay, I think yeah. So there was some coming to say that Anupam, thank you. So we will come back to all the questions in the Q&A sessions, guys. We don't have much time to it's already 20 minutes gone. Yeah, I have only 60 minutes to cover all the slides. Okay, fine. So this is about other types. Okay, and I just want to show you the sample of the flat files actually. So this is a sample of a flat file. Hope you guys see it. So this is an example flat file, and which is unstructured data, and it has been converted into structured data and stored in an Oracle database. Okay, this is first block is database conversion. And here you see IBM DB2 to Oracle database, which is database migration. And here is your BI, Publisher Enterprise. Okay, this is just for reference. Okay. So next is which is an important topic, just like things you should know being a DB expert. And those are OLTP, OLAP, ETL, data lake, data warehouse, data mart. Okay. We'll see what all those things next slides. So OLTP and OLAP. So online transaction processing, online analytical processing. Okay. I will start with an example, guys, to understand better. Okay. So when a salary is credited to your account, you'll be paying all the credit card bills, sending some money to your parents, sending the rent to landlords, okay, and paying some electricity bills, paying internet bills using Google Pay, okay, or any other UPI. So all these transactions are OLTP. So all these transactions will be stored in a database uh, as a transactions, each and every transactions. Okay. So in the next day, after you pay everything, I know it will be zero, but still, let's assume we will have some money in your account. So after paying all the bills, next day, assume HDFC. I'm using HDFC. So HDFC have an option to they will send a message in the morning about what is your available balance. Okay, so this OLTP transactions is being carried out by you using Google Pay. It's been stored in a database, and it's transformed into as a data set. Okay, and it will be the ETL will be processing your data, and will make some aggregation, and will send you the data to the balance database server. You can assume from there you'll be getting the messages. So that is OLAP. Okay. So it handles recent. So OLTP, we'll talk about OLTP. It handles recent operational data. Okay. And OLAP is all about historical data. Okay. And sizes are up to like 10 GB, but here 1 TB to PB. Okay. So uses simple queries, complex queries, faster processing speeds since it is single transaction, slower processing speeds because it deals with bulk loads. Okay. So here OLTP requires read write operations. Here it requires only read operation. So this is about OLTP and OLAP in high level. Okay. And next is about 4Ds in database. Okay. So one is database. Second one, data lake, data warehouse, data mart. Okay. I will just give you a simple explanation about about all these four things. Okay. Okay. So here, if you see data lake, okay, data lake is something which is unstructured. Okay. It's a raw data. Okay. Assume there is an ingestion of semi-structured and unstructured data sources, which is big data, from the equipment readings, telemetry, data logs, and streaming data. So if you assume, just assume there is some CNC machines, and in manufacturing industries, they'll be using some IoT technologies to read all those data from equipment. Okay, starting from the weight of an object, from size, centimeters, meters, everything. All these data will be in unstructured actually. So these will be stored in a data lake. So these data are being used by data scientists. Okay. And next thing is database, which is a structured actually. So OLTP again, which I told you a good example of Google Pay. And again, I have spotted some examples here. E-commerce, uh, a website creating an order for a product has sold. Okay, you're ordering a product and add cart and purchasing some product. So that is transaction again. So online transaction processing will be stored in a database. Okay. So data warehouse. What is data warehouse actually? It's again structured, and again, I'll just give you an explanation on Google Pay and HDFC available balance text message you will get. Okay. Again, I've given you something here about Toyota conducts market research and analysis large volumes of data in depth. Okay. So Toyota will conduct some market research according to the data available in the data warehouse. Okay, which the source of this data warehouse simply it is database. Okay. So what is data mart? It is again a structured data. It is a subset of data warehouse. Okay. So to be in high level, you will get all the data for your domain specific things. Like, so if a Toyota conducts a market research and analyze large volume of data, so data mart will have all the data related to different domains. So Toyota's finance database, Toyota's marketing's data, Toyota's HR department's data. So all these things are subsets of data warehouse, which is nothing but a data mart. Okay. So this is about data lake, database, data warehouse, and data mart. Okay. And next thing is ETL. So ETL is another vast topic which I cannot cover it in this session. I'll just give you what a high level of what is ETL. It is nothing but extract, transform, and load. Okay. And guys, ETL testing is different, and database testing is different. Hope you understand that. So why? Because ETL testing is performed in data warehouse system, and database testing is performed overall all the data, all the levels like data lake, data warehouse, database, data mart, everywhere. But in end of the day, both ETL testing and database testing deals with the quality of the data. Okay. So hope you know what is extract, transform, and load. Extract is nothing but extracting a data from flat files. If you just remember the flat files which I showed you in the references section. So those are the flat files. You'll be extracting the data. That is extraction process, and you'll be transforming that particular unstructured data, like filtering, cleansing, preparing. Which is all the data which is extracted. Okay, so that is transformation. So according to the business, we will have set of business rules how to transform data, right? So that is about transformation. And next, after the data is transformed, we should load the data into a data warehouse, right? So it's nothing but writing the data into a database. That's about ETL in a very high level, but it's a very vast topic. We should have a separate session on this actually. Right. Next is like DB testing process. Okay, so first comes preparing the environment. Okay, test data preparation in testing environment. Okay, so you can prepare your test data in UI, and if you have any write access or update access in your source DB, you can do that. Okay, and depends upon the project actually. So this is first thing, preparing the test data and the environment. Okay. Next is like perform data load. Okay. So once data is available in your source system, you will be running ETL jobs to load the data into a target system, right? So that is about performing a data load. So free advice here is learn how to run your ETL jobs and run it on your own to identify complex bugs easily. So if you run the ETL jobs on your own, you can easily view the logs of the ETL run, where in turn will show you where is the miss. If there are any error, easily we can just highlight and log it as a bug, right? But I know few companies have permission, few doesn't, but it depends again about the project. Okay. And next thing is like run the test and check the test results. Okay. Here again, exploratory testing and context driven testing comes to the picture. You'll be identifying the risks and convert it into your test ideas for betterment of your testing. Again, this is another topic about exploratory testing and CDT, but still it is useful in database testing as well, right? And the fourth step is, it's not carried out in all of the systems. It's like an incremental data load. So this is an optional actually and done based on the requirement. And again, uh, so there'll be existing data in a database. You'll be loading one more set of data into the same database. So it should not affect the existing data, which means the stability is tested there. So that is like perform incremental data load step. Okay. And the last thing is like report your findings. Guys, do not look for your expected results. Just report your findings. We're not. So that is a good way of testing again. We don't want to expect what will be what result will be, and we'll be searching the results instead of instead of reporting the findings. You'll miss all many bugs there. Okay. This is about the testing DB testing process which is carried out. Okay. And next is like database testing techniques. So these are the testing techniques which are carried in my project, right? And globally actually. So hope you guys know what is acid test, SCD test, counts validation, duplicate check, business logic testing, column hierarchy check, threshold testing, data quality testing, monitoring ETL execution, integration testing, constraint test, error table validation. Okay. So we'll see what all those things briefly. Okay. So this will show you what is acid counts, duplicate, and SCD. Okay, acid means atomicity, consistency, isolation, durability. So what is atomicity? So this is a property actually that states that a transaction must be treated as atomic unit, which means either all operations are executed or none of the operation are executed. Okay, so it should not be like, so no state in a DB, the transaction is left partially completed. So everything should be completed or it should be zero. That is about atomicity here. Okay. And next is consistency. So DB must be consistent after every transactions. No transaction should have adverse effect on existing data in a database. Okay, so that is about consistency. And isolation is again like if many transactions are carried out parallelly. So assume there are two tables are loaded parallelly. Okay, there should not be any impact by one transaction to other transaction. So everything should run in a smooth way parallelly. So that is isolation. Okay. Durability. So durability is nothing but when a system fails during data is loaded into a table, DB should have all the latest updates. It should not lose the data which is already committed. So that is about durability. Okay. So these are acid properties of a database test. Okay. Next is counts check. Again, it's counts between the source and target should match. Again, it depends on the requirement actually. The source and target count should match according to the business logics. You can reiterate. Okay. So duplicate check is duplicate entries are not allowed in a table, which will impact the quality of a product. You will see duplicate entries. If you see duplicate entries in the table, it will impact the customer dashboard or metrics dashboard, which is not a good sign. Okay. So next is SCD. So what is SCD? SCD is slowly changing dimensions. Okay. So we have different types there, type 1, type 0 to type 6, but most commonly used are type 0, 1, 2, 3, 4. Okay. So type 0 is something like no changes are allowed in a table. Okay. That is type 0. So if you are updating something, those updates should not be reflected in your table, that in simple terms. So type 1. What is type 1? No history, only current data should be shown in a table. Okay. So type 1 means keeps the latest data, old data is overwritten. So we will not be seeing. So for example, my name is Dilip. I'm updating it as Dilip Kumar. Okay. Dilip Kumar will only be displayed. Dilip will not be displayed. That is type 1 uh, type of table. Okay. So what is type 2? Okay. So type 2 is like Dilip will also display, Dilip Kumar will be displayed. Okay. With the flag, is current flag, which is usually used by all the engineers. So is current will be 0 and 1. Okay. So 0 means history, 1 is current. Okay. So in the current row, we'll be having Dilip Kumar as my updated name. Okay. Third thing is like, type 3, it's like adding a new attribute to the stored changed value. So in order to show the previous value before update, we'll be having a different column which is updated, which existed before update. Okay, that is type 3. Okay, and type 4 is like history maintained in a different table. So he will be using a different separate table to track all the history records. That is about type 4. Okay. So these things are about slowly changing dimension properties of a table. So these things we have to test it. So it depends. It will be the product owner will be defining a table property, whether it can be a type 0 or type 1, 2, 3, 4. According to these types, you will be testing accordingly. Okay. Next is business logic test. Every database testing will have a data mapping sheet. Okay. You'll be having different data logics, like, for example, if a column, country column name is India, INDIA, and in source, okay. So for assume source is the DB2 database, and if it goes to Oracle database, the target tables column should display IND, only the short name of a country. Okay, this is a simple business logic. So these business logics will be defined again in a DMD sheet, which is data mapping document sheet. We should ensure all these mapping logics are passed. Okay, that is business logic testing. Detail error, detail monitoring. So again, as I told you, when you run your jobs on your own, you will find bugs easily. So monitor the logs of an ETL execution to find what happened during the data load. So logs table. So we will be having a log table, control tables, which will show which table data load is in progress, and which is not, which is errored, okay, which is delayed, everything. So you should monitor those things also in the database testing. Okay. And next is like threshold test. So it's like what amount of data can a table withstand? Okay, like bytes allotted for a column. Okay, and maximum records that can be processed by an ETL. Okay, for example, only sometimes 5 million records can be processed by an ETL, but your source will have 7 million records. So at that time, your ETL will fail, right? So we have to test those threshold, how much data it can withstand to, your ETL can process. Okay, that is about threshold. And column hierarchy is again data should be displayed in correct columns. Okay, for example, country name cannot be displayed in your name column. I mean, in your person name column. Country should be displayed in the country names column. Okay, so that is something you have to check again, column hierarchy, because we will see most of the misses in the UIDs and the character data types. We'll be finding more misses there. Okay. Next thing is like data quality. Again, never compromise in quality of the data. If a source has a timestamp with 24 hours format, your target should also have a 24 hours format based on the business requirement. The business requirement is asking you, is telling that it should have a 12 hours format, then it's fine, but still the timestamp data type should be maintained. Next is error table. So every table process will have error table. Okay? Like it will store all the error records. which records are not processed by an ETL. So those things will be stored in error table. Okay, so this is like check for reprocessing error records. So in the incremental loads, you will be checking whether the error records has been reprocessed or not. This is one way of testing again. Integration testing. Integration testing is like collaborating between other testing teams. It's like a pair testing sessions, which can be conducted in order to maintain the quality of product again. Okay. So constraint checks, I hope you all know, not null, unique, primary key, foreign key. So all these things should not be violated. Everything should be satisfied. Okay. This is about different DB testing techniques. And you can frame your own testing techniques based on your requirements, as I told you before. Okay. And based on the business logics and the product discussions. Okay. And next thing is like automating DB test. Okay, so automation becomes more interesting when it comes to database. Yes, guys, we can also automate database testing. Okay, so we can also run regression test suits uh, using Selenium, Python, everything. Okay, and again it involves some complex queries. Okay, to perform these testing. Okay, Selenium, Python will have a set of database libraries and ODBC drivers to connect your database, and you can write your own queries to execute it in your Eclipse or using Selenium. Okay. And regression tests like count check, duplicate duplicate check testing, business logic rules, and other existing functionalities which will not be changed in your product can also be automated. Okay. And recently, the robot framework, which is in Python, is very useful for database testing, which has a numerous supporting libraries. We're exploring and we have implemented a lot of testing, DB testing efforts, test cases here. Use of robot framework. It is very useful actually. Yeah. So coming to the last thing, last slide, this is about the myths related to database testing. Okay, and I'll tell you what is people think it's a very tedious job. Yes, it is. I know, but just tell you, it's effective and efficient database testing provides long-term functional stability to overall application. Thus, it is necessary to put your hard work behind it. But it's not a tedious job, but hard work is needed. So, database testing add extra work. Okay, so yes, it's not like adding extra work. Okay, if you add more, I mean, actually database testing will add more value to your product quality. Okay, that is not like adding extra work. Okay, so database testing slows down the over development process. This is actually uh, being taught by most of the engineers and UI testers and other development team, even the product team. But it's not like that. Database testing is very important, and significant amount of database testing helps in overall improvement of the product quality. Okay, which is like one-time investment again. Okay, and it is costly. Yeah, everything. If something deals with database, it is costly. Yes, and it's not costly. It's like long-term investment actually. It will improve the robustness of an application. To be frank, yeah. So that's it from my side, and